this side Krishnendu Roy, and what I'm going to present is the heat and mass transfer. That is basically a course for BTech mechanical engineering students, and this is a very important course. You know why? Because the BTech mechanical has something to do with thermodynamics, has something to do with heat transfer, has something to do with fluid mechanics. और आप लोगों को पता ही है कि heat transfer is a full course subject. So heat transfer is a very important subject. Moreover, not only in the case of this course that you are pursuing, but also for your future run. Because suppose, I am basically a HVAC engineer, that is heating, ventilation and air conditioning engineer. Okay, I have worked in many of the organizations, many of the companies all over the world. Now, what we used to do is, because if you cannot estimate the air conditioning load for your building, then how will you actually go for the sizing of the equipment? So heat is the main thing that you need to take out from the building. Okay, so for that you need to know many things like overall heat transfer coefficients and then the thermal resistances. All these we will cover in this particular lecture. We'll try to cover in this particular lecture. Okay, so let's begin, and it's a very basic thing that today we will show. So this is basically unit 1. This particular slide will cover the unit 1 of your course. Okay, so this is the basics of it. Heat transfer, the basics. Okay, so it's the lecture 1, and I am Krishnendu Roy, associate professor of Indraprastha Engineering College, Ghaziabad. Okay, so let's begin. Okay, it's the same thing. Now, what we will understand is, we will understand the heat transfer, and we know, all of us, we know that heat transfer basically comes in 3 ways. Okay, so the first way is the conduction, the second way is the convection, and the third way is the radiation. Okay, so conduction is something to do, the heat transfer within the solids. Convection is basically heat transfer from solid to liquid or from liquid to liquid. Radiation is something else. Radiation can also occur in vacuum. It does not require any material for it to transfer. Okay, so let's begin our slide. The first slide tells us the heat always moves from a warmer place to a cooler place. We all know that we need to establish delta T. Delta T means the temperature differential across the two points. Suppose if one point is at 50 degrees Celsius, so for heat to take out from 50 degrees Celsius part, you have to have a lower temperature on the other part. So suppose if you have 50 degrees Celsius in point A, so point B should be at least 1 degree Celsius lesser, 49 degrees Celsius. So it will be better that if you increase the delta T for better heat transfer. So 50 degrees Celsius, 25 degrees Celsius. So 25 degrees Celsius of delta T. So more the delta T, more better will be the heat transfer. Okay, so heat always moves from a warmer place to a cooler place. What's next? Hot objects in a cooler room will cool to the room temperature. Okay, so what is the thing? Suppose if this is the room, okay, suppose you are living in a room, okay, and if you take one hot object, suppose आपने कोई एक गर्म चीज जो है, if you keep it in the room, if you keep it in the living room, and if you turn the fan on, okay, and suppose the room temperature is 35 degrees Celsius, and that hot object is suppose 60 degrees Celsius, what do you think? What will be the temperature drop? The temperature will actually drop from 60 degrees Celsius to approximately 38, like that, 38 degrees Celsius or 34 degrees Celsius. Why not below 34 degrees Celsius? Okay, so 34 degrees Celsius, it won't come down to 34 degree, it will go below 34 degrees Celsius, just because you are not deploying refrigeration. Refrigeration is a science, is a technique where you go below the ambient. So here we are talking about natural cooling. We are talking about natural cooling with some forced element like fan, blowers, anything, right? So those elements will not bring the temperature down the ambient. Okay, so to bring the temperature down the ambient, you need to deploy the technique of refrigeration, so which we are not discussing in this particular session. So refrigeration is again a course, students, in your it's a full-time course. Okay, so you need to check out the lectures for the refrigeration later on. Okay, so what we have learned is heat always moves from a warmer place to a cooler place, and hot objects in a cooler room will cool to room temperature only because you're not deploying refrigeration techniques into this particular scenario. Okay, and cold objects in a warmer room will be heated to room temperature only. Okay, so cold objects, and suppose if we talk about the hot objects are coming down, means the temperatures are coming down to room temperature. Similarly, cold objects will naturally be heated up in to the room temperature. It doesn't require anything else. The nature itself will heat that particular cold object to the room temperature. Okay, and if you have to go beyond the room temperature, you need to deploy something called heating. Heating means you can actually deploy boilers, you can actually have some room heaters, anything else than the nature. Okay, नेचर कुदरत जो है वो आपको सिर्फ रूम टेम्परेचर तक की ही सहूलियत देता है. अदरवाइज यू नीड टू टेक something else into consideration like refrigeration for cooling down, and heating. For heating you need to go for boilers. Okay, what's next? The question. I have a question for you. If a cup of coffee and a red popsicle, you know what is popsicle? Popsicle मतलब आपने वो जो आइसक्रीम खाई होगी जिसमें एक डंडी सी होती है, that is called a popsicle. Red popsicle मतलब लाल कलर की आइसक्रीम. Suppose if a cup of coffee and a red popsicle were left on the table in this room. It's a very important question, and this question related to the previous slide that I've just shown you. If a cup of coffee and a red popsicle were left on the table in this room, what would happen to them and why? Okay, so what do you think? What would happen to them? Then let's see. The cup of coffee will cool until it reaches the room temperature. As I have already told you, the cup of coffee will not cool down below the room temperature as you have not deployed or as you have not used any refrigeration technique. Okay, so in nature it will only come down to the room temperature, and the popsicle will melt, and then the liquid will warm to the room temperature. And as we all know कि अगर आप ice cream रखते हैं, it will definitely melt. Okay, because the heat transfer has to take place from room temperature to the popsicle temperature, and popsicle is frozen, so it has got lesser temperature. Room temperature is higher than the popsicle temperature, so therefore heat will flow from hotter object to colder object, and here the room is the hotter object and the popsicle is the colder object. So when the heat penetrates into the popsicle melts. Okay, and then that melted popsicle, or you can say that solution, or that particular liquid, the flavored liquid, will now be warmed to the room temperature, because you cannot go beyond it, because you do not have any room heater or boilers or whatever, any heating source which can elevate the temperature from room temperature to the other level. Okay, next. Now we have already told you, I have already told you about the heat transfer methods, right? So heat transfer methods are basically three. We all know that. First of all, the conduction, the convection, the radiation. Now we will see in good animation. Okay, so what is conduction, how it occurs, what is convection, how it occurs, and what is radiation, how it occurs. Okay, so let's, can you see this? It's a very lovely animation. See, if I am pointing this heat out, if I am saying this is my heat source, okay, if this is my heat source, it is burning, and you can see these lattices, these are basically atoms. Okay, so these atoms are actually vibrating. Okay, why it is happening? So please try to understand this. These atoms, these lattices has extra electrons. Okay, those extra electrons in electrical circuit carries charges in coulombs, and in heat they in heat circuit they carry heat. Okay, so we need to have extra electrons. Metals do have extra electrons, so those are the carriers of charge as well as heat. Okay, so here you can see that this there is a fire, and suppose if this is a metallic bar and these gray balls, those are jumping here, are basically carbon atom. Okay, so when this is being heated up, the electrons are actually jumping from higher shell to the lower shell, then again the heat is falling on that particular atom, and then it is actually the last electron is actually gaining that energy and is again jumping from this atom to this atom, and the same thing is happening from this end to this end. Okay, so suppose if this is point A, so energy picked up by one last electron, that is the unstable electron or the electron that is in the unstable shell, okay, is being picked up from here, and it is constantly changing its motion and it is getting transferred from point A to point B. Okay, so this is how conduction happens. See, if you can see this, as you heat the metal, the particles vibrate. These vibrations make the adjacent particles vibrate, and so on and so on. The vibrations are the metal, and so is the heat. What we call this? We call this as conduction. Something we call this as conduction. Okay, so this is something you should be knowing, that how the conduction occurs. Okay, now let's talk about something else. See, the metals are different. Okay, the outer, if you see, the outer electrons of metal atoms drift and are free to move. That's what I have just explained you. The outer electrons are the most unstable electrons, and those electrons are free to move. If those electrons in an electrical circuit, they will carry charges, and if they are in a heat circuit, they will carry heat. Okay, so the outer electrons of the metal atoms drift. So from point A to point B, from one atom to other atom, they actually keeps on bouncing. Okay, so the number of free electron, the more the number of free electrons are, the better will be the heat transfer, or the better will be the charge transfer in electrical circuit. Okay, now when the metal is heated, the sea of electrons gain kinetic energy. Okay, the kinetic energy is due to the quanta of heat that is being received by those electrons which are actually bouncing from point A to point B. Okay, and transfer it throughout the metal, as I have already shown you. Okay, now the insulators such as wood, such as plastics, have these sea of electrons as well, okay, but the thing is, they do not have that affinity. Affinity means the electrons are more stable in insulators than in metals. Okay, so metals does have numerous amounts of electrons. Those are unstable, ready to bounce from one atom to another atom just after receiving the quanta, but here they do not conduct, means the insulators also has those kind of electrons, but they are more stable. So even after receiving the quanta, they do jump from one atom to another, but the amount is lesser. So insulators, they does transfer heat, but the amount is very less than the metal, which instantaneously transfer heat or charge. Okay, let's see something else. See, why does metal feel colder than wood if they both are at the same temperature? And the answer here, as you can already see, the answer here is actually the same. Okay, just the slide that we have just seen before, the answer is actually you can just get it from there. Okay, so metal is a conductor, wood is an insulator. Metal conducts the heat away from your hands. Okay, wood does not conduct the heat away from your hands, as well as the metal. So the wood feels warmer than the metal. Okay, so the thing is, metal does have numerous amount of free electrons which are actually unstable, so ready to bounce from one atom to other atom, whereas insulator also does have these unstable electrons, but the quantities are very less. So, and since the quantity is less, so therefore the heat transfer will be lesser. So that's why you can see the wood does not conduct the heat away from your hands as well as the metal, so the wood feels warmer than the metal. Okay, so wood conducts the heat immediately because it has got more unstable electrons, whereas the wood does have unstable electrons, but the quantity is not much, so that's why wood is called as an insulator. Okay, now what happens to the particle in a liquid or a gas when you heat them. Okay. So if you see it's there, what happens to the particles in a liquid? Now we are discussing convection. Okay. So what happens to the particles in a liquid or a gas when you heat them? अच्छा, अब आप देख सकते हैं कि there is a square, ठीक है, वहां पे आप देख सकते हैं कि the particles are very much closely kept. Okay. So that is basically a liquid. Okay. और आप एक नीचे arrow देख सकते हैं, that's a red arrow. Okay. This is an arrow here. Okay. So this arrow is basically heat. ये आपको दिखा रहा है ये heat है. Okay. ये liquid है. This is liquid. Okay. And ये जो आप देख रहे हैं, एक बार आपने इसको हीट किया, ठीक है, एक बार आपने इसको हीट किया लिक्विड को, तो ये किस में कन्वर्ट होगा? It will be converted into gas. And we all know that the spacing of the molecules in gas is much more higher than in case of liquid. Look at the spacing in the liquid and look at the spacing in the gas. Okay, the spacing is much higher in the gas. So what is happening actually? You are actually creating randomness into it. You are actually giving energy, and due to randomness you are actually increasing its energy to move away from its boundation forces, to move away from its attachment bonding forces. Okay, so once you break that bonding forces, you are providing heat. So once you are breaking the bonding energies, now they are free to move, and once they are free to move within the boundary limits, the spacing increases. Okay, you can see the spacing has increased. Okay, so the basic idea is that you are actually, you know, breaking that bonding energy. You are providing so much of it that you are breaking that bonding energy, and the molecules are not moving apart just by giving heat. So this is basically, you know, what happens when you heat a liquid. So this is what happens. Okay, so this affects fluid movement. The particles spread out and becomes less dense. Okay, so this affects fluid movement. Okay, what is a fluid? A fluid could be a liquid or a gas. Okay, so this is the basis of convection, because you know the convection is the heat transfer between a solid and a liquid, a solid or a gas, or liquid or a gas, gas to gas, liquid to liquid. Okay, so it requires fluid, it requires heat. So fluid could be, what is a fluid? Then this fluid could be a liquid or a gas. So this is the particular thing. Okay, so this is all about this thing. Okay, so let's now, can you see the fluid movement? Okay, cooler, more dense fluids sink through warmer. I will just explain you what's this, but let's see this. Cooler, more dense fluids sink through warmer, less dense fluids. In effect, warmer liquids and gases rise up, cooler liquids and gases sink. Okay, we will just see it in the next slide. Okay, now can you see this lovely video? Okay, what you can understand with this video? By looking at this video, what do you think? What's happening here? It's a very basic phenomena of convection. Okay, and due to this phenomena, we have our weather systems. Okay, if we do not had it been not present in the atmosphere, or had it been not present on earth, then we wouldn't have our weather systems. अब ये कैसे हो रहा है? आप ये देखिए, this is a beaker which you are heating it up. Okay, आपको अब दिख ही रहा होगा, you are just heating it up. What's happening is, when the surface of the beaker is getting heated up, okay, the water adjacent to the bottom of this plate is getting heated up. Okay, and just now I have shown you in the previous slide that the less dense, hotter the fluid is, okay, the less dense it's become. Okay, now since there is a difference in the density, now since the density has reduced because this water is actually getting heated up. Okay, so this water will actually rise. Okay, and we all know that in nature we cannot maintain anything in vacuum, and we are blessed with the atmospheric pressure unlike other planets. So there won't be anything in vacuum, so the cold fluid will actually come down to take the vacuum, created by updraft of the hot liquid. Okay, so this is a very lovely video. Okay, the same thing as I have already told you. Why is it windy at the seaside? See, the land is warmer than the sea. Okay, the land is warmer than the sea. Okay, the cold air from the above the sea moves into the land. Okay, why it's happening? See, the land is warmer than the sea. Okay, this land warms the air above and it rises. So what happens is, suppose if this is the land and this is very much warm. Okay, so what happens is, as we all know, that the warm air rises because there is a density reduction. So just now I have told you that nothing can be kept in vacuum naturally because we have an atmospheric pressure over our head. So the cold air from the sea will actually try to take its place. So that's why if you're standing near the seashore, you will have good gusty winds touching your face. It will be very much windy, very much breezy. Okay, so that's why this convection is very much important to build a nature system. Okay, so let's go. Okay, so where is the freezer compartment put in the fridge? See, this is the freezer. Okay, so basically the hot thing, the hot thing is here. Okay, the hot thing is here, and the cold air that is coming from the freezer compartment, okay, it's coming down, taking the heat away, and the hot air is rising, and the freezer base is very much chilled, and this hot air, while in contact with this chilled pipes, it is getting cooled down, and you know this is heavy or dense, this is light. Okay, so the same thing, the convective currents are set up here. Okay. Now let's come to the third method of heat transfer. How does the heat energy get from the sun to the earth? So this is a very important concept. There are no particles between sun and the earth, so it cannot travel by conduction or convection. So by what method it travels? It travels by radiation. Okay, very important thing. So this is short wave radiation. When it enters the earth atmosphere, that will be long wave radiation, and we will discuss it in the radiation slides. Okay. Now these are certain questions. Radiation travels in straight lines. True. Radiation can travel through vacuum. True. Radiation requires particles to travel. Actually it will be radiation requires particle to travel. It is here. This is the correct one. Radiation travels at the speed of light. True. Okay. So the radiation requires particles to travel. No, it doesn't require any particles to travel. Okay. So the false is the correct answer. Otherwise, it wouldn't have come from sun towards earth. There is no particle there. Okay. As you can see in the previous slide, there is vacuum here. No particles. No particles. It wouldn't have come from sun to earth had there been any particle. Okay. So let's. Okay. So 4 containers filled with warm water. Which container would have the warmest water after 10 minutes? Shiny metal, dull black, or shiny black? Let's see. The shiny metal container would be the warmest after 10 minutes because its shiny surface reflects heat radiation back into the container, so less is lost. The dull black container would be the coolest because it is the best at emitting heat radiation. So what he's saying, that the shiny metal container would be the warmest. The shiny metal container would be the warmest because its shiny surface reflects heat radiation. It is reflecting, whereas the dull black is actually emitting the heat. Okay, it is only emitting the heat, and the amount of radiation that is falling over the black surface, if it is a complete black surface, it will absorb everything. Okay, so that's why. Okay, so let's go to the next slide. Absorption experiment. Just now I've told you the absorption experiment. The 4 containers were placed equidistant from a heater. Which container would have the warmest after 10 minutes? Shiny metal, dull black, and the shiny black. The options are again same. The dull black container would be the warmest after 10 minutes because its surface absorbs heat radiation the best. The shiny metal container would be the coolest because it is the poorest at the heat radiation. Okay. Okay. Convection questions. Now let's since I've already told you about the convection, I've shown you some animations of radiation, of convection, as well as of conduction. Okay, so let's discuss about the questions. Why does the hot air rise and cold air sink? Cool air is more dense, as I've already told you. The cooler air is more dense than warm air, so the cool air falls through the warm air, and since we cannot have vacuum naturally, so definitely the cool air comes to take the place of the warm air that has gone up due to density reduction. Why are boilers placed beneath hot water tanks in people's homes? Let's see. Hot water rises. So when the boiler heats the water and the hot water rises, the water tank is filled with hot water. Okay. Why are the houses painted white in hot countries? White reflects heat radiation, just now we have seen, and keeps the house cooler. Why are shiny foil blankets wrapped around marathon runners at the end of a race? The shiny metal reflects the heat radiation from the runner back in this, stops the runner getting cold. Okay, it's just, you know, the shiny part, you know, the it reflects more, so that's why more amount of heat gets wiped off. Okay, so let's have these multiple choice questions. Which of the following is not a method of heat transfer? Which of the following is not a method of heat transfer? Radiation, insulation, conduction, and convection. And it is pretty sure that it has to be B, insulation. Insulation is a kind of material that doesn't have free electrons. That has free electrons, but they have more stable electrons than the unstable ones. In which of the following are the particles closest together? So it has to be solid. Okay, it has to be solid. Okay, how does heat energy reach the earth from the sun? So it has to be radiation. Okay, which is the best surface for reflecting heat radiation? So it has to be shiny white. Which is the best surface for absorbing heat radiation? So it has to be dull black, as I've already told you. So dear friends, that was all about today's lecture. This is basically regarding the basics of heat transfer. It's the very basic of heat transfer by some and I've tried to show you a bit of animation so that, you know, the illustrations are quite helpful for you to understand, and I hope you could understand by this, and thank you.